With the nodes domain layer fully finished and having the INoteRepository interface ready, we can finally jump into the application layer to implement a few node blocks. Those will be responsible for loading all the nodes and performing actions with nodes such as deletion. Hello, welcome to ResoCoder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. In this 15th part of the domain-driven design Flutter series, where we are building this kind of a note-taking app, we're going to go into the application layer of the nodes feature. We're going to implement two blocks, and those are going to be called Note Watcher block and then also Note Actor block. Why are there going to be multiple blocks for the notes feature? Actually, those two are not all the blocks that there will be. There will be one more block, the Note Form block, but they will come later on. So why are there going to be multiple blocks, right? Well, the thing with blocks is that while they are very easy to work with when it comes to representing a certain state, you can easily organize the states in your head as you are building them, and it really provides a nice, clean code. The thing is that it turns out that combining something like loading nodes from Firestore and then acting on a note, like for example, when we long press on a note, we want to be able to delete it. Combining those two things, so loading and deleting, for example, is quite hard to perform from just a single block if you want to keep your states and events in check, if you want to keep them clean. So that's why the watching of nodes, either completed or only uncompleted, and then what I call acting on those nodes. So for example, deleting nodes, those two functionalities are going to be performed from separate blocks. They are all going to call methods on the single INoteRepository, which has the delete method, as it has the watch all, watch uncompleted, and then create an update methods. So INoteRepository is only a single one, but the blocks, we're going to have multiple of them. So let's go now into the application folder for the application layer, and we are going to create a new folder, which is going to be called Notes. And this Notes folder will hold all of the different blocks which are associated with the notes feature. So now it means that we want to have here the Note Watcher and also Note Actor blocks. So let's right click on the Notes folder. We're going to say block, new block using the VS Code extension, and let's call this one Note Watcher with underscore. We don't want to use equatable because we are using freezed. And it's going to create something called block inside the notes folder. We want to rename this block folder to say Note Watcher. And now, before we get into the nitty-gritty details, let's also create another folder here containing a block. This one is going to be called Note Actor. That will be responsible for performing the deletion of a note. So Note Actor. No, we do not want to use equatable again. And as we've seen before, let's rename this to Note Actor. Okay, we are going to first focus on the Note Watcher block, and then we are going to come over to implement Note Actor. And also, as always, you can get the code from the link in the video description to check it out at your own pace. I always like to start implementing blocks by modeling their states first, because state is something incredibly important when it comes to blocks. This is what gives the block actual meaning. All of the other things are just like the implementation details, but states are the main thing which the block operates with. So again, we do not want to use simple classes for states. We instead want to use freezed unions. So while we are at it, let's also run the build command. It will be available from the video description also. So Flutter pub run build run watch delete conflicting outputs. You know the drill. So while this is running, we are going to create an F union. Let's call it node watcher state, which I have just copied from the previously generated class by the extension. And now we want to provide the first union case for the state, which is going to be initial. Let's give it an underscore here. And this is nothing too extraordinary. Initial state is almost always present. This just means that nothing has happened yet. No event has arrived into the block just yet. Let's also come over to node watcher block and add the PTF statement. So part node watcher block.freeze.dart, so that we have some sort of a location for the generated code for the events and for the states, which are going to be freezed unions. Let's also repair this failing line by saying node watcher state initial. And of course, let's make it constant also. And that's about it for the block for now. Let's come back to the state. And actually, let me also hide the freezed files. So I have changed the extensions which I use for hiding generated files. Now I use something called hidden something explorer exclude, this one. So check it out if you are interested. The previous one, which I have shown you a few episodes back, just doesn't work very reliably. It sometimes doesn't hide the files. So if you have a lot of generated files, and you probably do, unfortunately, with the current state of unions and data classes in Dart, then you may be interested in explore exclude. So to make the files hidden, I will just go down here in VS Code, tick freezed G and git keep files. Okay. And yeah, now they are hidden. Cool. So with the state, what are going to be the additional states? Well, they're just going to be load in progress. This is for the time while we are waiting for the communication with Firestore, and we are going to show the expected circular progress indicator. Let's give this a name, load in progress. Okay, and let's copy them down. The next one will be load success. Let's also change the class name. And the last one will be load failure, of course. Load failure. All right. So load in progress will not hold any value in itself. It will just be by itself representing load in progress. But for the success and failure states, we do need to be able to put something into those states. So the list of nodes or the actual node failure. So in the case of blocks, we do not represent success and failure with an either type like we do inside the INoteRepository. So for example, here from watch all, we return a stream of either node failure or KT list holding node entities. So this is cool for repositories, but for blocks, for their state, we want to break it down to be even simpler than the either type. So instead of either, we actually create our own union, as you can see. So the success state will hold only the KT list of nodes. Let's call it nodes. And let's import kt.dart and also node.dart, the entity. And in the case of failure, it's just going to hold node failure. Let's call it node failure again. And that's it. We have just basically split the either type into our own custom union cases. And as you can see, the state of this block is absolutely simple. And this is why we are splitting the blocks into multiple ones. So we are going to have the node watcher block, which we are just now building for only loading the nodes from Firestore, and then a different block for deleting nodes from Firestore or performing other actions if there are any in your case, in your app. And by doing this, as you can see, our states and block logic will remain absolutely dead simple, and that's what we want always. We do not want to complicate things unnecessarily if we can instead split it up and make it much simpler. That's basically the single responsibility principle in action. As you can see, it really works. So now that we have the state, let's go over to implement events. Events which we want to have for the node watcher block are going to be watch all started and watch uncompleted started, because if you remember, in the app we want to be able to watch all of the nodes and also only the uncompleted nodes, and we have such methods even inside this INoteRepository for watching all and watching uncompleted. So let me copy the node watcher event name. We're going to again create a freezed union node watcher event. The first one will be called watch all started. Let's also name the class accordingly. All right, let's make it private also. Now let's go below. We're going to say watch uncompleted started. And this should be it, right? Well, it's not going to be it. We are going to see in just a bit why we need to create yet another event. But for now, logically, we could say that these two events are all there is to our node watcher event union. So now we can go over to the node watcher block and start implementing it, right? So we want to mark this node watcher block as injectable. So add injectable, and this will allow us to inject the block or use getIt to obtain the instance of the block rather, but also this will allow us to inject other instances of classes to the block. So we want to inject an INoteRepository in here. So let's call it INoteRepository and let's populate a constructor with it. Currently there is no actual instance which is going to get injected, but once we implement the repository interface into a real actual class, that class will get injected in here under its interface type. Now we want to implement map event to state. So just as we have done previously, we are going to say yield each and use our union type event.map, select all the nulls by hitting Ctrl-D or Command-D on Mac, and we are going to say block event handler using the extension, and you can always get this code from the link in the video description, of course. And I'm not sure why the the coloring of the brackets stopped working in this project for now. I could just restart the Visual Studio Code, but I don't really want to do it. But I guess I'll have to, so I'll be right back. Okay, so now with the highlighting of the brackets working, we can get into implementing the watch all started event handler. Over here, of course, we want to first yield the loading state, so load in progress, note watcher state, load in progress, and let's also make it constant. And as soon as we indicate that load is in progress, we want to say INoteRepository dot watch all, because we are inside watch all started. And if this was not returning a stream, but it would be instead a future, which you may be more used to, then we would just do something like await, right? Await this, put this into notes, something, right? It doesn't work, of course, like this because it's a stream, but if this were a future, you would do this, and then you would yield the note watcher state, load success or load failure, depending on whether or not the nodes is left or right of either, right? But the problem is that this is a stream, this is not a future, so we cannot just await it and yield it as simple as this. What we need to do instead is for each and every event or element coming inside the stream, we want to also yield a new state. Now I'm going to show you one way to do it, which will work only if you have basically one event and you do not plan to switch between watching all of the nodes and watching only the uncompleted nodes. And by implementing this the incorrect way, we are basically going to have all of the code ready for the correct way. We're just going to copy it later. So yeah, the incorrect way is incorrect because the stream which we are about to yield each, is never going to stop. This will cause that any kind of an event saying that we should, hey, stop watching all of the nodes and start watching only the uncompleted ones. This event telling the block to switch what it's currently watching and yielding is not going to have any impact because of the way that streams and asynchronous generators in Dart work. That's sort of unfortunate, and this will cause us to write much more boilerplate code than is necessarily should be needed, right? But let's go with this. In the ideal world, we should be able to yield each element coming from the stream where we are watching all of the nodes. But because, of course, we cannot just yield either node failure or KT list, but we need to yield our own custom states, load success or load failure, we would not just yield it as simple as this, just saying INoteRepository watch all, but we would also need to map the simple stream holding either into the custom union cases. So we would map each and every failure or nodes, which is of type either node failure or KT list node, into failure or nodes dot fault, and if we operate with the left side of either, which means failure F, we want to return node watcher state dot node or load failure, pass in the failure. And if we operate with the right side of iter, which holds the list of nodes, we will want to yield or return from this mapping function node watcher state dot load success and pass in the nodes, right? Now we do have some errors. I suspect that we are missing a parentheses. That's correct. Now let's put a comma here so that it's more nicely organized. And we would call this a day. Yield each is pretty self-explanatory because we want to yield each and every thing which is coming through the watch all stream mapped into our own custom load failure or load success. This would work perfectly fine for only one event. If we, for example, had only watch all started, this would be cool. But the problem is that if we want to switch to watch uncompleted, then we are not going to be able to do that with the current approach. The reason for that is that this yield each statement, or however you want to call it, is never going to stop emitting states. That's because it's only going to stop when this original stream coming from the node repository is going to emit the done event. In other words, when the repository's watch all method is going to stop itself. But that is never going to happen while we have this screen, this page open. The stream will always be actively looking for changes and pushing the changes from Firestore to us. So it's never going to emit the done event. It's never going to be finished. And therefore, this yield each contraption is going to, for all intents and purposes, we can call it an infinite yield loop if you want it. This will cause that we are not going to be able to switch to only watching uncompleted nodes. So what can we do with this? Well, we have to go with a different approach to mapping the incoming either of node failure or KTLIS node into our node watcher states. That approach will involve not yielding each, but instead basically adding a very redundant but needed event to the block. Let me show what I mean. We're going to come to the node watcher event file again, and in here let's create a new event which is going to be completely present here only for the sole reason of what I have just extensively described. It will be called nodes received. Let's also rename the class. And it's going to accept an either node failure or KTList node. Let's call it failure or nodes. Okay, so, and again, we probably need to rerun the build command. Whoops. Okay, let's rerun this. So this event is going to really just be called from within the block, and it will allow us to switch between watching all of the nodes and only uncompleted nodes, because of the way that the yield each statement works, that it's going to arrive in an infinite loop, so to say, otherwise. So now we have another event. We need to handle it, which is the beauty of using the map function on our freezed unions. parameter nodes received is required. So let's implement it as block event handler. And now from watch all started, instead of yielding each and mapping the original stream to our states, we're going to do something completely different. We are instead going to listen to the original stream. Let's leave the map in here for now. We're going to listen. Let's rename the event parameter to nodes. And with each such nodes or failures coming into our listen function, we just simply want to add to the block a new event called node watcher event nodes received, and pass in the nodes. And maybe let's rename the parameter to failure or nodes to make it more in line with the other names which we have. And yeah, of course, let's remove the yield each statement or yield each keyword from here. And this should really work. Now, before we go ahead and tweak it a little bit, let's also put some code which is going to emit the proper states into the nodes received event handler. Basically, we want to just copy the code which was previously inside the map method. So let's copy this failure nodes.fold, and we are instead going to put this into the nodes received event handler. And we are just going to use a simple yield keyword, not yield each. So yield event failure or nodes dot fold, and we want to fold this thing which was previously inside the map function. Now it's here. So we are folding and mapping the failure or right side of either to their respective states. Doing things like this is going to allow for switching between watch all and watch uncompleted nodes, because we are not using the yield each keyword, which is going to put us into an infinite loop. Basically, here we are only listening, and we can cancel the listening for all nodes and instead start listening for only uncompleted nodes very easily. So how can we cancel listening to all nodes to be able to switch to the uncompleted ones? Well, to do that, we need to store the stream subscription, which is returned from the listen method. We're going to store this stream subscription as a field inside the node watcher block. It's going to be a mutable field, stream subscription, and it's going to hold the either node failure KT-list node. Let's copy that and let's call it node stream subscription. Okay, now we want to add the subscription to this field whenever we call listen here. So let's say node stream subscription equals whatever is returned from this listen thing. And I know that this code looks horrible, but what are we going to do with the Dart formatter? I mean, yeah, it's not pretty, but it works. That's the important part. And now to see the full meaning of why we have this node stream subscription, let's actually start implementing the watch uncompleted started event handler. So let's copy the watch all started code into watch uncompleted, and we are just going to change watch all to watch uncompleted, and that's it. So why do we have this node stream subscription? Well, because it will allow us to cancel listening to the previous stream. So, for example, if the user decides to switch from watching all of the notes to only the uncompleted ones, then what we want to do is inside the watch uncompleted started to say that we want to note stream subscription dot cancel, and let's also await it as it's an asynchronous function. So this way, if we were previously listening and watching all of the notes over here, now we're going to stop that and start watching on the uncompleted notes, right? Now, because by default, initially, the note stream subscription is null, it's not assigned, we actually need to use the safe access operator. So question mark and dot, also called Elvis operator, if I'm not mistaken. And this way we are safe. Now all we need to do is for the user to be able to switch back to watching all of the notes. Let's copy this cancellation of the note stream subscription. We're going to also do it from within watch all started. Now this block is like 99.9% fully implemented. The last thing which we should do for a good practice and also for eliminating any possible memory leaks, which in this case could result in unnecessarily observing data from Firestore, which would result in you being billed for what you actually don't even see on the screen. So that's not what we want to do. And that's why we are going to implement the close method of the block. Close. It's going to be overridden because block is in itself a stream. So that's why it has the close method. And in here, we are going to say again, await note stream subscription cancel. And let's make this function async in itself. Okay, so that's it for the note watcher block, where we looked at a very interesting caveat of why we cannot use the yield each statement or yield each keyword, excuse me, but we need to use the weird approach of having a separate event just for yielding our own states. Now we're going to implement the note actor block, and this one will be a complete breeze. It's not going to have any such caveats and it will be very quick to implement. So let's go over there to note actor. Let's close off all of the note watcher classes. And now inside note actor state, again, we're going to start with states. We want to have a union for the state. So let's say f union note actor state. Let's import freezed. Let's go into the note actor block right now, and we're going to add the PTF statement also. Cool. And the first state again, which we want to have here, is initial, just like in the note watcher state. Again, even with an actor block, which is going to be responsible for performing actions, of course, on the individual nodes. At first, nothing is being done, so this means the state is initial. Initial. Cool. Now let's go to the block and let's fix the error where we say node actor state initial, and let's make it constant. This will be the initial state of the block. And now let's implement, or let's define all of the other states which can be present when it comes to acting on a node. Well, it's going to be very similar to the watcher state, only here the names will be a bit different. Instead of load in progress, we're going to have action in progress, because deleting something from a remote database is asynchronous. So we want to be able to display some progress to the user. So let's just copy this event multiple times down below. and we are going to say action in progress. Call action in progress. Simple as that. And the next one is again very similar to what we had in the watcher block. This one is going to be delete failure, because actually the only action we are going to be able to perform on a node, at least when it's already created, is that we can delete it. So therefore we are going to have delete failure, and then also delete success, of course. And let's also name the classes accordingly. Delete failure, delete success with capital D. And again, failure should hold some sort of an instance of the failure. So note failure. But in the case of delete success, as opposed to the watcher block, there is actually no data to represent success because we have deleted something right now. So that means that data is no longer present. And that's why we are not going to have any fields inside the delete success union case. All right, now for the events, because we have the states fully done for the node actor block. So events will be very simple. There will be actually only one event, and it's going to be the deleted event or delete event if you are not following the naming conventions we have established. So let's create a F union again. Let's say node actor event deleted and deleted. And of course we want to be able to pass in a note in there. Notes, just like that. Here we go. Because we don't have any other action to perform directly from the list of nodes UI, this node actor event is not even actually a union. It's just a simple data class with a named constructor. That's because it has only one constructor. But we are going to call it a simple union because all the other events are unions. But if you had a functionality where you could, for example, complete to-dos right from the UI. So if you clicked on a to-do here, you would be able to complete it right from over the nodes list UI. Then you would have another event here called complete or to-do completed, something like that. And again, it would be here inside the node actor event. But the way we are going to implement the app, we're going to be able to complete a to-do only from the node editing form. So we have only the deleted event over here. And with this done, we can now go over to the node actor block and implement it, right? It's going to be very simple to implement. Actually, inside the map event to state, we cannot even map the events, or as we do in the node watcher block, we say yield each event.map. That's because the event is a union, but here, because we have only one union case, this makes the node actor event into a data class, not an actual union, so we cannot even map it to all of its possible union cases. So whenever a node actor event arrives into this method, we know that we are dealing with the delete event, and that's why we can start yielding action in progress right from the bat. So yield const node actor event, or actually node actor state, excuse me, it's going to be action in progress. Then we want to call INoteRepository, which we currently don't have. So let's again, as usual, add it here. Final INoteRepository, node repository. Let's add it to the constructor as final field, and let's also mark this class as injectable. Cool. So we want to call noRepository.delete this time. And what do we want to delete? Well, a note which is present inside the passed in event. So this one, note, event.note. Now this is an asynchronous method present on the repository, so we want to await it, and it returns something which we are interested in. That's a future of either a node failure or unit. So let's store this value inside final possible failure is equal to this, and now we want to yield different states based on if a failure occurred or if everything went as smooth as butter. So we're going to say yield, and we want to fold the possible feature or possible failure fault. And if there is a failure F, we're going to return node actor state delete failure and populate it with the F failure, which is a node failure F. And if everything is successful, because it's just a unit, there is no real data in the right side of either when it comes to deleting something from Firestore or from any other database which you use, because again, we are not being tied to Firestore. The only layer where we are actually going to mention Firestore is infrastructure, but as you can see, what we are building right now in this episode or even in the previous ones mostly is totally Firestore free. But anyway, we just want to return delete success nodes actor states delete success, and it can be constant. So let's make it constant, shall we? Okay, we are going to add a comma at the end so that it's nicely formatted. And just like that, we have implemented yet another block, which is the node actor block, and it did not even hurt. So we have node actor state, node actor event, node actor block, and also we have the node watcher state event and block, where you could see the little caveat of how to work with streams and yielding something coming from a stream inside the block. You need to create a custom event for that, which is basically going to be used only from within the block itself. As always, you can find the code written in this part of this tutorial series and the link in the video description. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at a job, go to flutter.education, link is also in the video description, to get the top curated Flutter news and resources aimed at improving your app development career. Over there you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you don't want to miss more tutorials like this, the next parts of this domain-driven design Flutter series and also other tutorials about Flutter, be sure to subscribe to this channel and also join Notification Squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. If this video helped you with all that we have done with this weird yield each behavior and all that, give this video a like and also share it with other developers who are surely going to find it beneficial too. Leave a comment if you have anything to say, and see you in the next video.